So here, folks, we have an electric motor, which is a device used to convert electrical energy into mechanical energy. Now, there are many different types of motors. This is a St. Louis motor, but all motors have certain features in common. You'll notice here with this motor we have two permanent magnets which are surrounding an electromagnet which is attached to this armature so that it can spin freely. Also notice up here we have a metallic brush and a second metallic brush here which make contact with a split ring commutator here, and you'll see that split in the ring right here. So let's take a look at how a motor operates. What makes the armature of the motor turn is simply the repulsion of that electromagnet for the permanent magnet. Now you'll notice in this position the north pole of the electromagnet is repelled by the north pole of the permanent magnet, and similarly over here there's repulsion between these south poles. That causes the electromagnet to want to spin. But after it spins, you'll see that the north pole, which starts out over here, if it spins half a rotation, it would now be attracted to the south pole of the permanent magnet over here, in which case the motor would no longer want to spin. It would spin half a turn and stop. That is the function of the split ring commutator here. The split ring commutator causes the current in the electromagnet to change directions, which causes the polarity of the electromagnet to change directions after half a turn. So what starts out as a north pole over here, half a turn later becomes a south pole. And we see that once again in this position, the south pole of the electromagnet is repelled by the south pole of the permanent magnet. Likewise for the north poles, this causes the electromagnet to spin another half turn. And this process repeats. Let's turn on our electric motor and see it in action. Once again, we see this conversion of electrical energy provided by our power supply into mechanical energy, or the kinetic energy of the motor armature.